Box plots, five-figure summary. Now in the last couple of topics we introduced the concept of data sets, sets of data, and how we can analyze data sets using averages and spreads. Averages such as the mean, the median and the mode, and spreads such as the range, the interquartile range and the semi-interquartile range. In this topic we'll look at how we can present data sets and information about our data sets. And the different presentation mechanisms we'll look at will be box plots, bar charts and pie charts. So let's start with a box plot. A box plot can be used to graphically display information about the range, the median and the quartiles for a data set. And the information required to be able to draw a box plot is called the five-figure summary, because we require five figures even, to be able to draw our box plot. So what are those five figures? Well, for the data set, we need to know the lowest value, L, the lower quartile, LQ, the median, med, and the upper quartile, UQ, and the highest value. So to be able to draw a box plot, we need five figures: the lowest value, the lower quartile, the median, the upper quartile, and the highest value. Now that's to be able to draw a box plot, but it also works in the other direction. If we are given a box plot, we'll be able to read off these five values from the diagram of the box plot. Now, one further bit of information before we look at an example: a box plot is usually drawn alongside a number line as shown, and the number line is there to give meaning to the diagram of the box plot, right? With the number line there, we can read off the values that the box plot represents, as you'll see in this example. So let's take a look at an example. Let's take an ordered data set, and the ordered data set we have here is 4, 5, 5, 6, 8, 9, 10. Now the median, you'll recall, is the middle value of an ordered list of data. The middle value for our data set here is the value 6, so 6 is our median. And the median splits the data set into two halves: a lower half of data, shown by the light green lines, and an upper half of the data, shown by the orange lines. And then the lower quartile is the median of the lower half of the data. The lower quartile is the middle value of the lower half of the data, and we can see that's 5 here. And the upper quartile is then the middle value, or the median, of the upper half of the data, and we can see that's 9 as shown in orange here. So we have an ordered set of data, we have the median, we have the lower quartile, we have the upper quartile, and as it's an ordered set of data, we also have the lowest value, that's right at the start, that's 4, and we also have the highest value, it's right at the end, it's 10. So we have our five figures, and how do we represent that on a box plot? Well, let's take a look at the median. The median is 6, and the median on a box plot is represented by the line, the vertical line within the box as shown. And the lower quartile is shown by the lower end of the box, and the upper quartile is shown by the upper end of the box. And now you can see why box plots are normally shown with a number line, because the number line gives meaning or value to the box representation. We can see that the lower end of the box is at the number 5, so the lower quartile is 5. We can see that the upper end of the box is at the number 9, so the upper quartile is 9. And we can see the line within the box is at the number 6, and this tells us the median is 6. Okay, you can notice that these two whiskers, cat-like whiskers coming out the ends of the box, one out the left-hand side and one out the right-hand side, these whiskers represent the lowest and highest values of the data set. So our lowest value is 4, the whisker at the bottom end represents the lowest value, and the whisker at the top end, our highest value is 10, and the whisker at the top end represents the highest value. So to be able to draw a box plot, we need five figures, and the five figures you can see: lowest value, lower quartile, median, upper quartile, and highest value. And then we can go ahead, we can draw a number line, and we can draw a box plot. And going back the way, if we're given a box plot with a number line, we can read off five values of that data set that box plot represents from the box plot itself. So we're given the box plot, we can look at the whiskers and we can read off the lowest value, we can read off the highest value, we can read off the lower quartile from the edge of the lower end of the box, and we can read off the upper quartile from the upper end of the box, and we can read off the median as the line within the box. So a box plot gives us very useful information about our data set, or we can draw a box plot to represent useful information about our data set. Okay, let's take a look at a box plot example question. The box plot shown represents the test results for class 4A. We're given a box plot in green accompanied by a number line in blue. The number line runs from 20 all the way up to 100 and represents the test score percentages for class 4A. In part A, we're asked what information can you derive from the box plot about the test results. In part B, we are told that another class 4B had a median score of 65 and an interquartile range of 35. And we're asked to make two valid comments comparing the test results for class 4A and 4B. Okay, let's look at part A. What information can you derive from the box plot about the test results? Now recall that a box plot is also called a 5-figure summary. So at the very least, there are 5 pieces of information we can derive from this box plot about the test result data set. And then taking those 5 figures, we should be able to derive additional information about the data set. So let's start with that. So averages, what average can we read from the box plot? Well, we can read the median. The median is the vertical line within the box plot, and we can see that the median for this data set that the box plot represents is 70 because the vertical line is at 70. Okay, what about spread information? Well, the whiskers of the box plot tell us the lowest value and the highest value, and we can see that the lower end whisker ends at 40, so the lowest value of this data set is 40, and the higher end whisker ends at 100, so we can see that the highest value is 100, so somebody managed to achieve 100% in their test, in the test that this represents. So if we have the lowest value and the highest value for a data set, we can calculate the range. The range is the highest value minus the lowest value, so that's 100 minus 40, so that's equal to 60. Okay, so we pulled out the lowest value from the box plot, we pulled out the highest value by reading the box plot, and then we used those values to calculate the range. Well, what else can we read from the box plot? There are 2 other figures we can read, and those figures are the lower quartile, represented by the lower end of the box, in this case 60, and the upper quartile represented by the upper end of the box, and in this case it's 80. Now when we have the lower quartile and the upper quartile, we can calculate the interquartile range. IQR is equal to the upper quartile minus the lower quartile, which is 80 minus 60, so the IQR for this data set is 20. So for part A, we not only derive the 5 figures that the box plot represents, the median, the lowest value, the highest value, the lower quartile and the upper quartile, but we use those figures to calculate the range and the interquartile range for this data set. Okay, then looking at part B again, another class 4B had a median score of 65 and an interquartile range of 35. Make 2 valid comments comparing the test results for classes 4A and 4B. Okay, now recall from our previous topics, we can compare results by comparing means or medians. We have the median for class 4A, it's 70, and now we've been given the median for class 4B, it's 65. So class 4A has a higher median than class 4B, and this means that class 4A had, on average, better results than class 4A. Now it's important that you use the wording on average. Class 4A had, on average, better results than class 4B. Okay, and then the next piece of information we can derive is that we know that the lower the interquartile range or the semi-interquartile range, the more consistent the results. Now, as we can see that class 4A has a lower IQR than class 4B, 20 is less than 35, so we can say that class 4A had more consistent results than class 4B. So for part B, we used the medians and we used the interquartile ranges to compare the two data sets. Okay, let's take a look at bar charts. I'm sure a lot of you are familiar with bar charts, but we can use bar charts to represent a data set graphically. So let's take an example. Let's look at the age of clients visiting a local gym, the example we used in a previous topic. If you look at this data set, we can create a frequency table for this data set. We create a frequency table for this data set by grouping the ages together in classes. So we have the age class 11 to 20, 21 to 30, 31 to 40, 41 to 50, and 51 to 60. And we'll represent all of these age classes in different colors. So we can represent the bars on our graph in different colors as well, and we can easily visually see through the colors which age class maps to which bar. Okay, going through our data set left to right, we would go through our tallies and mark our tallies and then count up our frequencies. But we'll summarize that for you. The age class 11 to 20 has a frequency count of 3. The age class 21 to 30 has a frequency count of 8. 31 to 40 has a frequency count of 4, 41 to 50 has a frequency count of 3, and 51 to 60 has a frequency count of 2. So we have our frequency table, which has our age classes and it has our frequency counts, and now we want to represent this information in a bar chart. So we draw on our X and Y axis for our graph, and on the X-axis we're going to plot the age classes, and on the Y-axis we're going to plot the number of clients. So for the X-axis, the age classes, we will have 11 to 20. We will have one bar representing the age class 11 to 20. We will have another bar representing the age class 21 to 30, another for 31 to 40, one for 41 to 50, and one for 51 to 60. Okay, that's our X-axis. On the Y-axis, we'll represent the number of clients, or the count, the frequency count, which represents the number of clients that visited the gym. So for the Y-axis, we need to pick a suitable scale. Now looking at our frequency counts, we can see the lowest value is 2 and the highest value is 8. So a suitable scale for us would be 2, 4, 6 and 8. Now that we have the X-axis and the Y-axis, we can draw on our bars. So let's take the age class 11 to 20, and we want to draw on a bar that goes up to a frequency count of 3, or a number of clients of 3, and let's draw that in the light blue as shown. Now let's look at the age class 21 to 30. This is a bigger bar. This goes up to a number of clients of 8 because the frequency count is 8. So we draw that in, and then we draw 31 to 40 as a bar going up to 4. 41 to 50 is a bar going up to 3, and 51 to 60 as a bar going up to 2. And that's our bar chart drawn. This bar chart is also called a frequency chart because it represents the frequency table and the frequencies of these age classes visiting the gym. Not all bar charts are frequency charts, but this bar chart happens to be a frequency chart because it represents the information in our frequency table. So that's all there is to drawing a bar chart. You take your information, you plot one set of information on the X-axis, and you plot the other set of information on the Y-axis, and you draw your bars. Now normally you'll see the bar chart drawn like this with vertical bars, but bar charts can also be drawn with horizontal bars. You could flip this graph around and you could draw the bars horizontally if you so wished. But this is the normal way a bar chart is drawn, with vertical bars. Okay, the last presentation mechanism we're going to look at is pie charts, something that you're probably familiar with as well. So pie charts are another way we can represent a dataset graphically. A pie is a circle, and as a full circle has 360 degrees, this full circle will represent all the quantity we have. So the full circle represents all the quantities within the pie chart. Each individual quantity will need to be represented as a fraction of 360 degrees. So each individual quantity will get its own slice of the pie, and that slice of the pie will be a fraction of 360 degrees. So let's take a look at an example in which we create a pie chart. We did a survey of the favourite sport across a class of 20 students, and the results we got were as follows. Football, there was a count of 10 out of 20 students. Football was their favourite sport. For rugby, we had a count of 5. For tennis, we had a count of 2, and for other sports, we had a count of 3, which covered things like basketball, hockey, etc. Now, going through this, football has a count of 10. Now, what fraction does this represent? This represents a fraction of 10 out of 20. So what would be the slice of the pie that football would represent? Well, that would be 10 out of 20 times 360 degrees. Its portion of the 360 degrees is dictated by the overall fraction that football represents. Football represents 10 out of 20, so it's 10 out of 20 times 360 degrees, and this is 180 degrees. So football's slice of the pie will be 180 degrees. Okay, what about rugby? Well, rugby represents 5 out of 20, so its angle or its slice of the pie will be 5 out of 20 times 360, which is equal to 90 degrees. Similarly, tennis will be 2 out of 20 times 360 degrees, which is 36 degrees. And other will be 3 out of 20 times 360 degrees, which rounds up to 54 degrees. So we've taken our counts, we represented those counts as fractions, and using those fractions we've worked out the slice of the pie for each of the 4 sports. Football is going to get half of the pie, 180 degrees. Rugby is going to get 90 degrees, or a quarter of the pie. Tennis is going to get 36 degrees, and other is going to get 54 degrees. Let's draw our pie chart. So our pie chart is a full circle. The full circle represents all the quantities within the pie. And let's draw on football. Football gets half the pie. Rugby gets a quarter of the pie. Tennis gets 36 degrees. Now you'd use a protractor to draw this if you were drawing this with pencil on paper. And other gets 54 degrees. And that's our full pie. It all adds up to 360 degrees. So we've taken our data set, our favourite sports data set for a set of 20 students, and we've represented that as a pie chart. We took the count for each sport, we represented it as a fraction, we worked out the angle or the slice of the pie for that sport, and thereby we were able to draw the pie chart. Now if somebody gave us this pie chart, we could look at this pie chart and quickly see that, you know, whether we know that it's a count of 20, 100 or 200 people that it represents, we know that half the people, their favourite sport was football, because half the pie is given to football. And we know a quarter of the people, their favourite sport was rugby, because a quarter of the pie is represented by rugby. So if we're given a pie chart, we can easily read off information from the pie chart, which gives us information about the data set. Now for things like other and tennis, because they're not a half and a quarter, you'd normally see a percentage right on top of the pie. You know, it'd probably say tennis 36%, other 54%. So you'd be able to, you know, visually see that percentage. You wouldn't have to get out a protractor and try and work out the actual percentage of the pie. So that's all there is to pie charts. We've kind of quickly covered how you can create a pie chart which represents a data set. In this topic we covered obviously pie charts here, we covered bar charts, and we covered box plots. A lot of useful information for you to take away on presentation of data sets. And now as always, it's time for you to go off and practice.